In this video, we will discuss a case, and the case is the collapse of the ceiling of a tunnel. Let us see what happened in this collapse. On 10th of July 2006, 3 concrete ceiling panels, each weighing 3.5 tons, collapsed from the roof of the tunnel. This tunnel was 4-point channel tunnel that connects Ted Williams Tunnel in the city of Boston. This accident killed one woman who was sitting on the passenger seat of a car and injured her husband who was on the driver's seat. This tunnel was part of a mega project known as the Big Dig, which started construction in 1991 and finished in December 2007. The initial project cost was $2.8 billion, but the final cost was $14.8 billion. So there was a big overrun of the cost. Let me show you where the channel tunnel is. Actually, this is the map of Boston, USA. So this is Boston. And here is the 4-point channel tunnel. So this tunnel goes under this channel, and this connects to the Ted Williams Tunnel, which actually goes to the Boston Logan International Airport. You can see the location of this channel tunnel, which is very close to the downtown, or almost in the downtown of Boston. And you can see on the other side of Charles River is MIT and also the Harvard University. So this is the location of the 4-point channel tunnel where the accident took place. You can also find a Wikipedia page on Big Dig ceiling collapse. The whole project was known as Big Dig, and it happened on 10th of July 2006. The total weight of the concrete that fell was nearly 24,000 kgs, 24 tons of concrete fell on a car. So you can see many information given here, and there are a lot of literature on this case, and you can find very informative literature here. Why did it fail? And also the archives of the original in PDF form. So you can go to this literature and read about this accident, why it happened. So let us discuss from engineering point of view what happened in this accident. 2 rows of 12 feet by 8 feet ceiling panels, each weighing 4,700 pounds, and 1 row of 6 feet by 8 feet ceiling panel weighing 2,500 pounds fell on a car that was traveling in the tunnel at that time. 3 rows of concrete ceiling panels fell from the roof of the tunnel. So the ceilings were on the roof of the tunnel, and the ceiling panels fell on a traveling car. Let me show you the very schematic drawing of a cross section of a tunnel. So here you can see concrete panels. So for example, these concrete panels are supported on a inverted T-shaped hanger rod and turnbuckle here you can see, and these hanger rods are fixed to the roof of this tunnel by bolts, and these bolts are inserted into the concrete and jammed with adhesive anchors. So this is a brief schematic of the tunnel, the panels, the concrete panels, and how the concrete panels were fixed to the roof. This shows the actual picture of the accident site. So here you can see some of these panels which fell down while the car was running on this road, on this lane, and you can see the rest of the panels here. So these panels actually fell down. These pictures have been taken from this reference here, so kindly go to this reference and read more details of this accident. This shows the drawing of the ceiling. So as I explained to you just now, that this is the grid panel of the ceiling, the hanger rod here, and this hanger rod is connected to the roof of the tunnel using these bolts, and bolts are fixed to the roof by adhesive anchors. This is in much more detail of the rows of which the panel actually fell down. This shows the schematic of the adhesive anchor. So in adhesive anchor, basically the bolt is inserted inside the concrete. So this is the concrete roof, and in the concrete we make a hole and the bolt is inserted. Before the bolt, epoxy is applied, and then the bolt is inserted inside, and basically the epoxy adhesive, which acts as an adhesive, jams the bolt. So all the weight of the hanger and the panel is taken by this joint between the epoxy and the bolt, and epoxy and the concrete. So epoxy basically acts as a glue here. This schematic shows how the adhesive should be applied. So holes drilled in reinforced concrete. So this is the hole which is drilled here. Holes should be cleaned before epoxy is applied. So this hole will contain many debris after drilling. So this debris should be immediately removed and the hole should be cleaned. Resin and hardener are applied separately into the drilled holes. Drilling holes too deep or applying too little epoxy can cause failure. So again, this hole should not be drilled too long, otherwise the epoxy will not go all the way to the end of the hole. And applying too little epoxy can also cause failure, because then you will not have good bonding between the concrete and the bolt. Third, screwing anchor bolt into hole mixes components. So as we screw the bolt inside this hole, actually because of this rotation movement, it will mix the two components of the resin and the hardener, which is very important. Unless they get properly mixed, they will not harden properly. The resin or the epoxy will not harden, and therefore it will be a cause of failure. Bolts must be cleaned for epoxy to adhere. The bolts that we used must be cleaned for epoxy to adhere. So normally in any kind of epoxy glue, it is a must that the two surfaces that we are going to join together must be clean. Epoxy must be given enough time to cure. Again, there is a certain amount of time that it takes for the epoxy to cure. Now here we will discuss the root cause of the failure. The original design required ceilings to be made of steel and concrete with epoxied bolts into the tunnel roof. The project manager decided to use a cheaper precast panel which weighed 2.5 times the original design panels but was easier to install. So this decision was taken by the project manager that they were going to use precast panels, but it was 2.5 times the original design panel in its weight. So it is much heavier than what was designed. Second, originally wedge anchor was proposed that can wedge inside the hole in the concrete. So wedge anchor is another way of fixing something to a concrete, and I will show you the picture of wedge anchor. Bechtel changed it to adhesive anchors. Consultants had warned against adhesive anchors which used epoxy as the adhesive as it was prone to creeping during fire. So there was already a concern that adhesive should not be used inside a tunnel because in case of a fire, if fire breaks out in the tunnel and let's say there are people inside, there are cars and vehicles all inside the tunnel and fire breaks out, then it will lead to the failure of the joints and thus collapse of the ceilings. So this was already mentioned by the consultants. This is the wedge anchor. Here you can see that this part actually flexes into the concrete and it stops the bolt from getting removed. So this acts as an anchor. So this is another way of anchoring a bolt to a concrete. Third, there were signs of bolts pulling out of the concrete hole in less than 2 months of installation. So during the project itself, people had found that the bolts were pulling out of the concrete. There was delay in decision making on this and the contractors completed the works on all the ceilings in the meantime. So from the project management side, there was a long delay in making any decision on this aspect. Why the bolts were pulling out. The contractor had found that the diamond core drill had left the hole very smooth with some residue material which was left at the end of the hole. No further action was taken on this. A very smooth surface inside the hole is not good for bonding between epoxy and the concrete. Again, any residue material left inside the hole will also cause problem in the bonding between epoxy and the concrete. Fourth, pull test was to be done at a higher load of 6,350 pounds instead of the recommended 3,250 pounds for all the lanes, but the contractor insisted that it could be done only on high occupancy vehicle lane as all the works had already been completed. So there was a good decision that the bolts should be tested under pull test at a higher load than what was recommended. However, it was not done for all the lanes. It was done only for the HOV lane. In this test, so the tests were conducted. In this test of 187 bolts, 19 had pulled out. Out of the 19 bolts, 17 were in the mock-up area and hence it was decided that the 17 had pulled out because of the inexperience of the workers in the initial period. Hence, it was decided that there was no problem. No panel in other lanes were tested. So this tunnel contained at least 3 different lanes. So HOV lane, then east and westbound lanes. So this test was not conducted in any other lanes. In the original design, power fast or a standard set epoxy was specified for the bonding purpose. But the project manager used fast set epoxy which had already shown inferior results in tests performed in 1995-96. So the standard epoxy had given satisfactory results. So here in the case of selecting the epoxy, a decision was made to use epoxy which was inferior in quality. In this figure, it shows this is the creep test. So where anchor displacement is plotted in terms of number in years. And the test showed that standard set epoxy had very little movement for almost more than 25 years, whereas fast set epoxy had very large movement or displacement of the anchor. So that means this epoxy was inferior in quality, and in a long-term test it showed that this could not give the right performance. Another important aspect is that pull test cannot give the required data on creep of a polymeric adhesive because pull test is a short-term test. Creep is a time-dependent property of a polymer. So if we want to know the long-term property of an epoxy or any polymer, it is important to conduct a proper creep test and not just a pull test. Post-collapse information. Investigation done after the collapse found that 200 bolts in the eastbound and westbound tunnels were loose, but none in HOV lane. So in HOV lane, the bolts gave quite good performance, whereas on the eastbound and westbound tunnels, 200 bolts were found to be loose, and the accident happened on one of these tunnels. The manufacturer of the adhesive knew that fast set epoxy was being used in the tunnel and not the standard set epoxy. So the manufacturer had the knowledge that fast set epoxy was inferior, but it was being used in the tunnel, not the standard set epoxy. Here you can see in this picture a bolt which has already come out of the roof, the concrete of the roof. So this kind of loose bolts were found in the tunnel during the investigation. Test conducted way back in 1999 had found the problem with the method of adhesive application. It was found that most of the bolt was bare, not enough epoxy was applied. So bolt surface did not have enough epoxy. The holes were not filled with epoxy completely before inserting the bolt. This had reduced the bonding strength between the bolt and the concrete by about 38%. So it is very important that adhesive is applied properly and enough adhesive is applied so that it covers all the surfaces which are to be bonded. Much of epoxy near the tip of the bolt was brittle and it crumbled easily. There was dust adhered to the bolt surface which affected bonding. So again, any surface which has to be bonded must be very clean and there should be no dust particle there. The holes in the concrete were made by diamond coring drills, which left very smooth surface, and the holes were not cleaned immediately, giving residue inside the hole that did not get removed even after cleaning. So another problem was that diamond coring drills were used, which left the surface of the hole very smooth. And also the residue of the drilling process should have been removed immediately, but it was not removed immediately, and therefore some of the residue got stuck inside the hole, which also affect the bonding between the bolt and the concrete. These pictures show the failed adhesive anchors. So these are the anchors which actually failed, and you can see that yellowed epoxy. So yellowed epoxy means basically it is degraded form of epoxy. So because of not proper curing, it can turn into yellow. Then you can see fractured epoxy near the tip of the bolt. So these fracture happened because of the brittle behavior of this epoxy. And also you can see void areas. So these are the areas where there were a lot of voids in this epoxy. So again, voids will lead to weakening of the joint. So similar voids can be seen here as well. So these were the issues that were found out after investigation.
A typical creep test is conducted by using a tensile experiment, for example. So here a specimen is fixed and it is put under tension. So at a constant stress, the extension in this specimen is measured. So after some time, this specimen will be extended by certain length. So we can plot the creep test data as time, and here will be extension or in the form of strain. So strain, which is epsilon. So epsilon will be given as delta L over initial length. So at time 0, when we apply the stress, there will be some instantaneous strain, for example, and after that it will follow something like this. So slowly this specimen will get elongated at a constant stress as we progress in time. So with time, the specimen is getting elongated. So this is a typical creep test that we perform in laboratory. In the current case, what has happened is we have the hole inside the concrete, and we have got the bolt. So this represents the bolt, and we have got epoxy here in between. So because of the heavy load, the pull force is quite large because of the big size of the panels. Because of the heavy load, there will be shear in the glue here. So this is epoxy. So there will be a shear. That means this part will get out of the hole. So there will be a relative motion between the concrete and the bolt. This is the epoxy. So this will be like a creep experiment. Just now we have shown. So just like a creeping of a solid, this epoxy glue is moving under stress with time. So there is a stress applied, and as time progresses, this bolt will slowly move down or get out of the hole. So this is what happened over a period of time. There were some other mistakes. For example, the epoxy was not applied sufficiently, so there were many dry areas. That means areas which had no epoxy. That's one mistake was done. Another was that there were a lot of dust particles inside the hole. So for example, some residue was there, a lot of dust particles. So because of the dust particle, the bonding between the bolt and epoxy was not complete. So there were a lot of dust particle here in between. So because of the dust particle, the bonding between epoxy and the bolt did not take place properly. Also, it was found that there were a lot of voids inside. So when epoxy has voids, basically the strength of epoxy is reduced. So because of the voids, the strength was also reduced. So there were several problems in this case, and that led to pulling of the bolt out of this hole.
So now let us discuss the issues with the bonding of the bolts to the concrete. Epoxy adhesive was used rather than undercut wedge anchors. It was decided that wedge anchors should have been used, but actually epoxy adhesive was used for bonding. Adhesive material selected was of inferior quality, especially in creep tests. So already they had found that the epoxy that was used was of inferior quality, but still they went on and used it. Diamond coring drill left very smooth whole internal surface and hence affected the bonding between the adhesive and the concrete. So as we know, anything that needs to be glued together, the surface should not be very smooth. So it should be prepared, actually the surface is roughened so that you have more surface area for bonding. Hole cleaning was not done immediately, which left unremoved residue inside the hole. Dust was found on the bolt surfaces. Adhesive on the failed bolts also showed voids which weakened the interface strength. Periodic inspections of adhesive anchors was not done to see the performance in any of the lanes. So here we can see that these were the technical issues with the bonding of the bolts to the concrete, which led to the failure. So probable cause. The National Transportation Safety Board of USA determined that the probable cause of the July 10, 2006 ceiling collapse was the use of an epoxy anchor adhesive with poor creep resistance. That is, an epoxy formulation that was not capable of sustaining long-term loads. So we can see that the problem that during the manufacturing, several decisions were made which were not correct. Decision about how the bolts should be fixed to the roof concrete, what kind of method should be used, and once the decision was taken about epoxy, then inferior quality of epoxy was used, and previously the design had recommended steel and concrete ceiling, whereas later it was decided that precast concrete should be used, which weighed 2.5 times more than the original design ceiling. So all these wrong technical decisions led to the failure. So what lessons do we learn from this? First is, money should not take precedence over important engineering decisions, because in this case we see that most of the decisions were taken based on the consideration of money. There was overrun of the cost. In order to reduce the overrun of the cost, the project manager took these decisions so that he could reduce the cost. But any such kind of decision can lead to major consequences in terms of safety. Engineering principles should be followed with proper live testing. Experimental data should guide any engineering decision. So here we see that whenever we have to take a decision on something which is very new, we must conduct an experiment and try to see the performance. No decision should be taken based on any other consideration but experimental data. And consequence of a wrong decision should be considered before any engineering project is started. That means whatever decision we are taking, if the decision is not based on proper experimental data, we should consider what will be the consequence if something goes wrong. So if something like a ceiling falls, definitely some major accident is going to happen, because that kind of tunnel or any passage will be occupied by people. So therefore, in engineering decision, we have to be very much aware of these issues, and especially this case tells us about the performance of polymeric glue or adhesive. So what is important is the time dependent test should be conducted. So no decisions should be made on a quick test. So this is very important from the materials point of view, and from general engineering project point of view, we can see that money should not be the primary concern, but rather the safety of people is more important.